Okay. Hi guys, good morning. Okay, we have 4 of you. Maybe wait for 1 more minute. Let your friends join. So guys, how was your tests? You wrote 2 tests. Did you find any difficulty? Any questions you didn't answer? You want me to ask something?
I had a doubt, sir.
Yeah, tell me. Tell me.
I'll take the question just a minute.
Yeah, sure. Take your time.
That's from the chemical bonding test, sir. Question 15.
No. Tell me the question. I don't know. I don't have the question.
Okay.
Tell me. Write the question.
Explain why O-hydroxybenzaldehyde is a liquid at room temperature, while P-hydroxybenzaldehyde is a high melting solid.
Okay. So O and P represents ortho and para. Okay, like hope you would have done hydrocarbons in your school. Have you done it?
Currently going on, sir.
Currently going on. Okay, no issues, Kanna. Like maybe wait, I'll share my screen. I'll let you know what is that. Okay, it's because of hydrogen bonding. Okay, let me share my screen. Wait. Guys, you can also come. Like anybody else, is anybody else doubts, please have it with you. You can clear it now. Like if you have any, like I'll just share my screen. Okay, if you are like seeing these things, whatever we are seeing here, these are for 12th class. Like these are organic. You also study about it, right? Anyways, so we'll move on. I'll just tell you what is that. Okay. So guys, okay, wait, I have to flip my screen also. 1 second. Yeah. So what is it? Ortho? What does it tell me, Rohan?
Explain why ortho-hydroxybenzaldehyde is a liquid.
Okay, benzaldehyde. Okay, fine. So, first of all, you know how to name these compounds. That's the first point. But again, you don't know that. And after knowing that, you have to know what is this O and P represents. That represents ortho and para. Okay, anyways. So let me tell you this. So when I have benzene, okay, we know benzene structure. Correct. So this is how we represent benzene. Correct. Right. This is not exactly how we represent. Right. So this is how I represent benzene, right? So I say assume that I have a substituent here. Like generally, all these are hydrogens. All the corners represents carbon atom, and all the carbon atoms has one hydrogen atom each. Right. Say now it is what it is. This is hydroxy benzaldehyde. Okay. So hydroxy group is OH. Right. Hydroxy group is OH group. Right. Okay. So when I say ortho is 1 and 2. Okay. This is first carbon atom. This is second carbon atom. So in the second carbon atom, you need to have an aldehyde, CHO. This is what is called as ortho hydroxy benzaldehyde. Okay. This is ortho. Okay, fine. Now it is para. Now see, I'll tell you 1 and 2 are para. Sorry, 1 and 2 are ortho. 1 and 3 are meta. And 1 and 4, if you have substituents, those are called as para groups. Okay, 1 and 2 ortho, 1 and 3 meta, 1 and 4 ortho. Again, from that side also you can have. Again, this is second carbon atom, this is third carbon atom. Again, you can do that there. Okay, so this is ortho. Now if I go to para, again, I have OH in the first carbon atom and aldehyde CHO in the second carbon atom. Right. So then our question is, why this is para? Okay. So why is it that this is in liquid state? right? And this is going to be in gaseous state. That's the question. Correct. Now it's pretty simple. It's because here I'm going to have
Sir, no,
intra.
sir. It's given that Y is ortho one in liquid at room temperature, while the para one is a high melting solid.
High melting solid. Okay. Anyway, so this is a liquid
Yes, sir.
and this is a solid,
Yes, sir.
right? Okay. Okay, no issues. Again, the answer is going to be same answer only. It's because here I'm going to have intramolecular hydrogen bonding. You can see that there is an oxygen, there is a hydrogen, so I can have some interaction between this hydrogen and this oxygen. That is intramolecular hydrogen bonding. But here there is no question of intramolecular because these two are very far away. So I need to have one more molecule of this, right? So that I can have intermolecular hydrogen bonding. That's the answer to this question. Okay, so obviously intermolecular hydrogen bonding is stronger than intramolecular hydrogen bonding. That's why they exist in solid state, but intramolecular hydrogen bonding is weak, and that's why they exist in liquid state. That's the answer to this question. Okay, understood?
Yes, sir. Understood.
Okay, but anyways, don't worry, guys. These kind of questions you'll be able to answer at the end of 11th class. Maybe you don't know the structure, that's why you were not able to answer, but you don't have to worry about it. This is just a test, right? No issues at all. But I think we discussed, right, this kind of questions when we discussed hydrogen bonding. Did we discuss?
So we discussed about intra and inter.
Intra and inter we discussed, but not about the benzene structures.
I think we did that also, sir.
Yeah, we did something. I did it with orthonitrophenol,
Yes,
and paranitrophenol. But same thing here. Just that the other group is different. Here, instead of NO2, I have a CHO. That's it. That's the only difference. Again, hydrogen bonding is the answer to this question. Okay. Right. Any other question, people? Anybody wants to ask? Okay.
So I have a question again.
Yeah.
In gaseous state.
Yeah.
1 minute, sir.
Mm-hmm.
So in the 13th question, give an expression for Van der Waals equation and give the significance of the constants in the equation and state derivatives. I didn't get the significance.
I'll tell you. So the thing is, you have Van der Waals equation is real gas equation, P plus a n squared by v squared into v minus nb is equal to nRT. Like this was the Van der Waals equation or the real gas equation, right? So now we know that we had some problems with your what is it called as kinetic theory of gases. There were some assumptions which were wrong, correct? Right. So what happens? So what are the two major assumptions are considered to be wrong? One is that the volume, right? The volume of the individual gas particles are negligible when compared to the whole volume of the container, right? So that has to be corrected, right? But that is not the actual case, right? They will be able to liquefy the gases. So the volume of the gas molecules, individual gas molecules, become significant, right? So at a point of time. Okay. So that is one thing. Second thing is that they said that there will not be any interaction. That is, there is no force of attraction. There is no force of repulsion between the individual gas molecules, right? So this again is wrong. Okay. So because of that, I have to have two correction factors. One is for the attractive forces or repulsive forces. The second is for the volume correction. So the Van der Waals constant A, we write A and B in the equation, right? So the Van der Waals constant A represents your force correction. That is the interactive forces are going to exist. So you're going to put a factor for that. And B is for volume correction. Maybe the second assumption is wrong. Volume correction. So A is for force correction and B is for volume correction. That's why that's how you must write the answers. Pretty easy.
Okay, sir. Yes? Understood now, sir. Thank you, sir.
Yeah. So we discussed so much on that. You can even remember the compressibility factors. If I have the attractive force or repulsive force, how the pressure will change, right? So yeah, like you can just go through the videos. If you just go through the videos for gaseous state, you will pretty much everything is told. Everything is told. Okay, fine. Any other questions, people? Okay, fine. So then we'll move on. Okay, so we were seeing ionic equilibrium, right? So I think last we stopped with the concept of conjugates. Correct. I told you what are conjugate. What do you mean by conjugate base of an acid, right? And also I told you what do you mean by conjugate acid of a base, right? So now what is the importance of that? I told you that you will be able to recognize whether an acid is a strong acid or a weak acid depending on the stability of the conjugate base, right? If the conjugate base is stable, right, I say that the acid is a strong acid, right? And vice versa for your base also. If the conjugate, if the conjugate acid is stable, but again, we'll not be using that term for bases generally, but we'll be using for acids for sure. The conjugate base, if it is stable, I'm going to get a strong acid, right? Okay, so I even gave you an example. We took HClO, HClO2, HClO3, HClO4, right? So in that case, the conjugate basis would be ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. ClO4 minus had the maximum number of resonance structures, so that's what is going to become more stable, right? So obviously HClO4 is the strongest acid among all four, and HClO is the weakest acid among all the four, right? So these all were told to you, and I told you that for a pair, for a conjugate acid base pair, this equation holds good. That is Ka into Kb is equal to Kw. Hope you remember this. Okay, this is on and on and on and only for the conjugate acid base pair. Not, you cannot use some random acids Ka and some random bases Kb, and you cannot equate that to Kw. This is only for a pair, that is an acid base conjugate pair. Okay, right, fine. So we have actually done enough, guys. I think we have to do some problems. Just give me a moment. I'll just bring the problems. 1 second. Okay. Okay, let's take this question. Ionization constant for a weak acid Ha, ionization constant for a weak acid Ha is 10 to the power minus 5. Right? Ionization constant of a weak acid Ha is 10 to the power minus 5. Now the question is, find the ionization constant. Find the ionization constant of its conjugate base A minus. Find the ionization constant of its conjugate base A minus. Okay, so there's an acid HA which has a ionization constant of Ka, and the conjugate base of it is A minus. Obviously, they're asking you what is the ionization constant of that. Okay, now tell me, how will you do this problem? What do you mean by ionization constant, guys? What do you mean by ionization constant? What are they talking about?
Kb only, no, sir.
Exactly, right. So when I say ionization constant or dissociation constant, anything, the names you see, those are all represent the equilibrium constants for the acid and the bases, right? So ionization constant, dissociation constant, all these names, if you see, those are representing Ka and Kb's for the acid and the base. Okay, now just now we saw that the equation is right in front of you, right? Ka into Kb is equal to Kw, right? I told you this will work only for a conjugate acid base pair, right? So they have given the Ka value of the acid. They're asking you the Kb value. That is, the base means Kb, right? The conjugate base is Kb value they're asking. That's it, right? So you just have to use this equation. As simple as that. Correct. So what is the Kw value, guys? What is the value of Kw?
10 power minus 14.
Absolutely, right? It's
The
10 power
Kw
minus.
is ionization of water, right, sir?
Exactly. I told you it's an experimentally determined value. You have to remember the value I told you. At 25 degrees Celsius, the value is 10 to the power minus 14. You have to remember that. Okay, this is how questions will be asked, guys. Right? That's why I told you have to remember the Kw value. Okay, so now Ka value is given 10 to the power minus 5. Right? Now Kb value I have to find. I don't know. Right? And what is Kw value? 10 to the power minus 14. Right? That's it. So what will be the answer? Kb will be 10 to the power minus 9. That's the answer. Right? So this, I hope you understood the importance of this equation. Right? Okay.
Yes, sir.
Okay. Next question. Oh, guys, I forgot to tell you one important thing. Okay. So like I'll give you a formula first. Okay. So I know pH. Right. I know pH is negative log of H plus concentration. Correct. Now, if I want to find the H plus concentration, this is the formula. I think I told you the formula, the concentration of H plus of, if I have at all pH value is given to you and they ask you what is the concentration of H plus, it's pretty simple. The formula is 10 to the power minus pH. Did I tell you this before? Did I give you this formula before? H plus concentration is 10 to the power minus pH. The pH will come in the power. Did I tell you this before? Did you remember?
I don't think you told
okay,
this.
anyways, no issues. You can just know the formula. It's pretty simple. It's coming from that only, right? Say now, that's how log works. Okay, so here I have the base 10, right? So now this 10 will go here and this will go to the power, and minus is obviously there. So that's why I have 10 to the power minus pH. Okay, so the H plus concentration is 10 to the power minus pH if the pH value is given to you. This formula you can use easily. So if I say that pH was 5, right? So the H plus concentration would be 10 to the power minus 5, something like that. Okay, right. Now, this is not what I want to tell you. This is just coming from the mathematics. What I wanted to tell you is, say, if I have an HCl, okay, I have an acid solution, right? And say the concentration of HCl is, say, 10 to the power minus 8 m. Okay, the concentration of HCl is 10 to the power minus 8 m. Right. Now, what will be the pH of this solution? Can you tell me? I have HCl concentration to be 10 to the power minus 8. Okay, now listen, if the same question I would asked you, now, okay, let me tell you this. Now I can tell from the HCl, this is the entire concentration of HCl, right? So since it is a strong acid, right, whatever is the concentration of the acid, right? That will be the same. That will be the same. That mean that value is the same as the concentration of the H plus ion. Why? Because it is going to be a strong acid, right? But if I've given you 10 to the power minus 8 m of CH3COOH, at that time you cannot directly take the H plus concentration as the acid concentration. You remember how do you go about it? You have to go for Ka. It depends on alpha, how much dissociation is happening, right? Degree of dissociation. But since it's strong acid, we always assume alpha to be 1. Okay, so whenever a strong acid is given to you, you can directly take the concentration of the acid to be the concentration of H plus. But if it's a weak acid, you cannot do that. You can find the concentration of H plus. Basically, the concentration of H plus in that case would be C into alpha. Hope you remember that, right? Concentration into the degree of dissociation, right? That will be the concentration of H plus from a weak acid. But if it is a strong acid, in this case, not only in this case, any case, if it's a strong acid, the concentration of H plus will be directly equal to the concentration of the acid. So in this case, the concentration of H plus is 10 to the power minus 8. Right? Hope you understand what I'm trying to tell. Okay, now answer this question. If I have 10 to the power minus 8 HCl, what is the pH value for this acid? Just plug in the equation. What is the formula for
8, sir?
8, right? So if you put it, so it will be negative log of concentration of H plus. Concentration of H plus is minus 8. Okay, so you know how log A to the power B works. I can write it as B log A. So this minus 8 will come this side. So you will have 8 minus gets cancelled. So you'll have basically 8 log 10. Right, 8 log 10. Right, so what is log 10 value? Log 10 value?
1, sir.
1. Guys, you have to remember all this, or else you cannot even do simple problems. Okay, so log 10 value is 1. So the pH of this solution is 8. This is correct or wrong? Tell me. Is this correct? Or if it is wrong, why is it wrong? This is not the exact value. Why it cannot be the value? Even though I don't know anything about anything else, right? But this value cannot be the value of the acid. Why?
Because it's above 7.
Absolutely right. I know if it's an acid, it should be less than 7. So what do you mean by this? This means that this acid is not an acid, it's a base. No, this is really not true. Right? So guys, whenever you see that the H plus concentration is lesser than 10 to the power minus 7, in this case it's 10 to the power minus 8, right? So let me tell you that. So whenever you see H plus concentration, right? Whenever you see H plus concentration to be less than 10 to the power minus 7, you cannot directly use the formula. Yeah, you are going to use the formula, but the thing is, this H plus is coming from the acid. Okay, now what do you mean by 10 to the power minus 8 m? That means the acid is so much diluted, right? I have so much amount of water and very little amount of acid. That's what it means, like when I have less concentration or more diluted acid. Okay, so in these cases, if you calculate, for example, if the H plus value is exactly equal to 10 to the power minus 7, you will find the pH value to be equal to 7. That means it's neutral. So again, that cannot be the answer. Okay, so what mistake are we doing here is that since I have some little amount of acid, okay, we have to take that H plus concentration, but there is so much amount of water. Okay, so that water also can give me H plus ions. Right, that water also can give me H plus ions. So whenever you have H plus concentration from the acid to be lesser than 10 to the power minus 7, the total H plus concentration, I'll write it as H plus T. H plus T represents total H plus concentration should be equal to the H plus concentration from the acid plus the H plus concentration right? Plus the H plus concentration from the water, W. Okay, now this value will be directly known because in this case it's 10 to the power minus 8. Now what is this value? This is the constant value, right? What is this value? H plus concentration from water. What is it? How much?
H plus values alone.
Yeah, the concentration of H plus from water. What is the value? You know the value actually. Okay, the clue is Kw.
10 power minus 7, sir.
Absolutely. How did you get the value of 10 to the power minus 14 for Kw? Because when I go for the ionization of H2O, it will give me H plus or no H minus. Correct. So the Kw value is basically going to be equal to the product of, that is basically H plus concentration into OH minus concentration. Right. So now if I have to get 10 to the power minus 14 for Kw, obviously H plus concentration is 10 to the power minus 7. OH minus concentration is 10 to the power minus 7. Correct, right? So this is the constant value, guys, right? This value is always 10 to the power minus 7, right? And this value will be given from the acid. You have to find it, like from say in this case the value is 10 to the power minus 8. That is given in the question. Okay, so you have to use this. The total H plus concentration will be equal to the sum of the H plus concentration from the acid and the water. Now you have to use this only for this case. That is only when the H plus concentration from the acid is lesser than 10 to the power minus 7, right? If the other cases, say if I have 1 m HCl or say 0.1 m HCl, right? So you can add, actually, even in that case, you can add this. You can add the H plus concentration coming from water. But in that case, even if you add, it is not going to make much. It is not going to make much of a difference. Okay, because that time the amount of water itself is very less, and obviously the concentration compared to the concentration of the acid is going to be pretty less. But if the H plus concentration is lesser than this value, okay, then definitely you have to go for adding the H plus concentration from water also. So in this case, it is not just this. If I have to find the pH value for this acid, it will be negative log of 10 to the power minus 7 plus 10 to the power minus 8. That would have been the answer. Right? It will be 10 to the power minus 7 plus 10 to the power minus 8. That will be the pH value. This would have been the pH value. And now if you check, it will definitely not be 8. It will be lesser than 7. It will be around 6.9 or something. Right? It will be around 6.9 if you calculate. Okay. Right. So this mistake, a lot of times I've seen questions coming, at least 1 mark, they'll ask you, they'll just give you 10 to the, find the pH of 10 to the power minus 7 HCl. And if you just write it as 7, you're going to get 0 marks for that. Okay. It is not just 10 to the power minus 7, it is actually going to be 2 into 10 to the power minus 7, because one more 10 to the power minus 7 is coming from water. Okay. So this I wanted to tell you. This is a very important point. Okay. Fine. Any questions? Everybody understood, I guess, right? Okay, if you have any doubts, you can ask me. Okay, now we'll go to the question, guys. Okay, take this question. pH of 0.08 m, pH of 0.08 capital M, HOCl, you know HOCl acid, HOCl is 2.85. Is 2.85. Right now they're asking find its ionization constant. Find its ionization constant. Right, so the pH value of 0.08 m HOCl is 2.85. Now they're asking you find the ionization constant of this acid HOCl. Okay, right? So they're asking you Ka value. That's what they're asking. Right. Okay. Now I think I have to add a page. Is there any questions? No. Okay. Right. So hope you've taken down the question, right? Okay. How do you do this question, people? Hope you remember that there are a lot of equations connecting pH, what to say, the Ka values, the concentrations, right? So let me list down whatever the formulas we can have, right? Say now you remember that Ka is C alpha squared. Obviously, you know, I have C alpha squared by 1 minus alpha, but we can just take this, no issues. Okay, so Ka is equal to C alpha squared. Okay, there is no alpha given to you. There is no this thing, but they need this value, right? They need Ka value, correct? Concentration is given. Concentration is what? 0.08 m. It's given to you, right? So somehow if I can find alpha, right, now that is going to solve my problem. Okay, fine. They have given me pH. Okay, now hope you remember H plus concentration from the acid is going to be equal to C alpha. Do you hope you remember, guys? Right, so H plus concentration, hope you remember how this comes. I have HA giving H plus A minus. Say now this is 1. Okay, C 0 0 C into 1 minus alpha C alpha. Okay, hope you see what is the concentration of H plus. It is C alpha. That's what I wrote here. Okay, so H plus concentration is C alpha. Right, now can I find the H plus concentration from the question? Yes, no? Can I find the H plus concentration from the question? Hello?
1 minute, sir, thinking. So I think we can. Sir.
Easy, right? How do you find it? pH is given, right?
We can use that minus log. Sir.
Exactly. So I know the H plus constant. What is the formula? Just now I told you it is 10 to the power minus pH. That's the formula, right? pH is given to you, right? So now what is it? It is 10 to the power minus 2.85. That is the H plus concentration. Now that is equal to C alpha. Concentration is given. Concentration is 0.08 m, right? So from this you will be able to find alpha and get this alpha here. Find the Ka value. Easy. Everybody understood? Or I'll repeat one more time. So pretty simple. So this is my what is a simplified equation for Ka. Basically, it will be C alpha squared divided by 1 minus alpha, right? But in this case, I just even if you want, you can take even 1 minus alpha, not a big deal, right? So now C alpha squared divided by 1 minus alpha. Now we know concentration. Concentration is given as 0.08 m. Alpha value we don't know. We need to find the Ka value. Right now, but they're giving me pH, right? So somehow I have to connect my pH with alpha. So I already know from this that the H plus concentration will be equal to C alpha. Correct. So now what is H plus concentration? We can find it is 10 to the power minus pH. pH is given to us, that is 10 to the power minus 2.85. Right. So now I know the concentration. I will be able to find the alpha, substitute the alpha here, find the Ka value. So obviously you need to know, you have to do some logarithms and all, because you have 10 to the power minus 2.85 and stuff, right? But you don't have to worry. Like anyways, in the exams, we'll be able to calculate easily, or at least they will give you the anti-log values directly. Something they'll do. They'll not make you. They make the calculation this difficult. Don't worry. Yes, everybody understood. I want S from everybody. Yes or no?
C here is 0.08.
Yeah, C is concentration. Concentration of the acid, 0.08 m.
We divide 10 to the power minus 2.85 with C. We get alpha value and then we substitute. Sir.
Absolutely. Absolutely. Yes. Yeah. Okay. Guys, everybody understood? Please give me a yes.
Understood, sir.
Okay, 2. There are almost how many? There are 9 people here. Yes, everybody understood.
Actually, I have a doubt, sir.
Yeah, can I tell me?
I didn't get what does that M stand for actually, sir?
M is molarity. No, we have studied about molarity, right? How do you represent molarity? Represent molarity with capital M. Okay.
Okay, sir, understood now.
Right.
I had a doubt on
yeah, guys. See, this small, see, if at all you didn't ask this, you would have been wondering what is this M, right? So I know for sure everybody will have this kind of doubts, and it's perfectly okay to ask me. I am not going to judge you. Your classmates are not going to judge you. Please, even if you think it's going to be a stupid doubt, I am not going to think it anyway like that. Right. So if you have anything like that, please ask me. Please ask me. Okay. So I still have 8 more people to let me whether you understood or not. Yes. Did you understand, guys? Hello.
Sir, I joined a little late, sir, today because I went to Tirupati yesterday, sir. So now only I came, sir. Sorry, sir.
Okay. No issues. Fine. What about others? Did you understand? I just want an yes or no. That's what I need.
Yes, sir.
Okay. Only 4. I still have 5 more people to respond. Okay. So this, I understand that. Yeah. Someone is speaking? No. Okay. And I understand that, right, what to say. And this is very easy to do in online class, right? You just, what is that? Just go log in, and then you can just keep the phone away, right? So I think that's what is happening. And if they would have been there, right? So definitely the answer. Anyways, I'll take it up. Okay, no issues. We'll go to the next question, people. Okay. Okay, take this question, people. Right. What is the degree of ionization? Right. What is the degree of ionization and pH? You have to find 2 things here. Okay. What is the degree of ionization? What is degree of ionization, guys? What is that? What is degree of ionization?
Alpha, sir.
Yes, correct. It is alpha. Right? Degree of dissociation or degree of ionization, all these are same. Okay, so they're asking what is the degree of ionization and pH of 0.5 m, that is the molarity, 0.5 m propanoic acid. Okay, propanoic acid, and they have given the pKa value. pKa of this acid is how much? 5. Okay, So again, I repeat the question. They're asking you what is the degree of ionization and the pH of a 0.5 m propanoic acid. You don't have to know the structure of propanoic acid, guys. You should know it. Maybe you should have studied in carbon compounds in a 10th class, right? So propanoic acid will have 3 carbon atoms with the COOH, right? Okay. Anyways, we don't go to the structure, and they're giving you the pKa value. pKa value of this acid is 5. Okay. What is pKa? What is the formula for pKa? I told you whenever this P comes, you have to do something. What do you have to do?
Introduce log.
That's the log?
Minus log.
Yes, that's it. So when I say pKa, pKa is nothing but negative log of Ka. That's what it means. Okay. So from this, can I find the Ka value, guys? How will you find the Ka value? Okay, and now I think I have to teach you some mathematics. Wait. So log works like this, people. So when I have log, okay, wait. So when I have log, oh God. Okay, when I have log A to the base B is equal to C. Now remember, this is the log of something value. Let's say log of 5, log of 6, something like that, right? So this B represents the base. Okay, so hope you remember the difference between ln and log, right? Ln will have base to the to the base E, and log will have to the base of 10 generally, right? Again, I can have any number. There's no this thing, but generally these two are the things that you use more frequently. Right. So log to the base E and log to the base 10. Okay, and I can have some value here. Okay. So anyways, so whenever you have this, right, now how else can I write this equation is you bring this B here and this C will go to the power and remove the log. Okay. So this equation, I'll be able to write it as A is equal to B to the power C. This you can write. Please remember this. Okay, so now what is the base here? I told you now we are use base to be equal to 10, right? So that is why when I say pH is minus log of H plus concentration, right? Now what is the H plus concentration? Now the base is 10, right? So if I have to find the H plus concentration, that's why I told you that it is going to be equal to 10 to the power minus pH value, because this 10 goes here, pH goes to the power minus pH. Still there's a minus sign. You can bring this side, so it will become 10 to the power minus pH. Okay, so please remember this log operation, right? It is not going to, nobody's gonna teach you this in the mathematics because you don't have logarithms in your syllabus. But maybe if you take JEE mains, yes, you have logarithm also in your syllabus. But anyways, you don't have to worry about it, right? So whenever I have log to the base B, which is equal to some value, so I can write it as A is equal to B power C. Okay, now that's how I got my H plus concentration also as 10 to the power minus pH. Okay, now can you tell me what will be the Ka value for this? From this, can you tell me? pKa is 5. Okay, so that is basically negative log of Ka is equal to 5. So what is the Ka value here?
10 power 5.
Again, you have a minus sign. Don't forget it. So it will be what?
10 power minus 5, sir.
That's it. Say Ka here. Okay, maybe I'll write here. So Ka from this, I can easily write it as 10 to the power minus 5. That's it. Guys, please remember this. Again, this 10 goes here. Again, obviously, there is, if I remove the negative sign from this, and if I put it here, right? So what will become? Ka value will become 10 to the power minus 5. Pretty simple. Okay, now, or if you want to remember it as a formula, please remember it as a formula also. I can say that Ka will be equal to 10 to the power minus pK. That's it. This formula, if you want, you can remember. but it's better to remember the mathematics. It is anyways going to be useful in the future also. Okay, so just like how you have H plus concentration is equal to 10 to the power minus pH, Ka value is equal to 10 to the power minus pKa. Okay, or you use the mathematics or you use the formula. Either way, I want to do the problem. That's what is more important. Okay, fine. Now we can go back to the question, right? What did I ask you? Which question I asked you? I forgot. Yes, what was the question I asked you? Okay, this one. Understood. Find the degree of ionization and the pH of 0.5 m propanoic acid, and they have given you the pKa value. Okay, right? Can you do this problem, guys? I'll give you, what is the time? Okay, we have almost 10 minutes. I'll give you maybe 2-3 minutes. At least get the approach. You don't have to get the answer maybe, right? But get the approach. I'll give you 2 minutes. Go for it. Just please bear with the are you getting any background noise? An auto running or something?
Yes, sir.
Okay. So I stay in Mylapore, right? So even though you stay inside the house, the streets are pretty small. So there is obviously, like, even if something happens on the road, we'd always hear it. Even though if you're gonna still sit so much inside the house, close all the doors, that happens.
So I got alpha square, sir, but I'm not sure.
Okay, tell me the approach of the problem.
We found K, sir. K is 10 power minus 5. We can use K equal to C alpha square to find alpha.
Okay,
So
C is given,
K
right?
by C.
Cool. Yeah.
K by C equal to alpha square we can use.
Okay, so it's basically root of Ka by C. Correct.
Then I got alpha square as 10 power minus 4 by 5.
Okay, that we can find. Alpha we can find. So one question is answered. Degree of ionization is answered. Okay, well, how will you find the pH? Again, use the H plus concentration. What is H plus concentration in terms of concentration and alpha? If you know the H plus concentration, you can use the pH value, pH formula too. That is negative log of H plus concentration that you can directly use. Right. So I think from whatever Rohan told, you must have understood what we're trying to do here, right? So now we have found the Ka value. Ka value is negative 10 power minus pKa. So Ka is 10 to the power minus 5, right? Now, just now we told this, we can use this, which is equal to C alpha squared. Now, C is given to us. C is what? C is 0.5 m. Right now I can find alpha, so I can alpha will be equal to root of 10 to the power minus 5 divided by 0.5. You can do the calculations later. This is what is alpha. Done. Right now they have asked you one more question. They want a pH value. So pH, right? Oh god, again. So pH is negative log of H plus concentration, right? Now I know H plus concentration from this thing. Hope you remember it is it's equal to C alpha, right? So basically you can write you can find the H plus, or you can directly use the formula, whatever it is, right? So C value we know that is 0.5, alpha value we just found out, right? So I know the H plus concentration. Okay, so that's it. You have to put it in the formula and find the pH value. So if I want to find the H plus concentration first, that is equal to concentration, that is 0.5 into the alpha value which you found just now, that is root of 10 to the power minus 5 divided by 0.5, right? This is H plus concentration. Take this H plus concentration, put it here, find the pH. Okay, right? Everybody understood?
Understood, sir.
Right? Okay, I think only 4 of you are at least listening. Okay, anyways, so guys, everybody understood? Like one said yes, others, is it okay?
Yes, sir.
Okay, good, right, fine. You can do the calculations later, people. We'll do one more question. Okay. Take it on the question. I mean, this is the last question for the day because we have only 5 minutes. Okay, so I have 200 ml of 200 ml of HCl solution, 200 ml of HCl solution of pH is equal to 2, 200 ml of HCl solution of pH is equal to 2 is mixed with 300 ml of 300 ml of NaOH solution, 300 ml of NaOH solution of pH is equal to 12, 1 to 12. Right? Now they're asking, what is the pH of the resultant mixture? What is the pH of the resultant mixture? Okay, repeat the question. 200 ml of an HCl solution of pH is equal to 2 is mixed with 300 ml of NaOH solution of pH is equal to 12. That's it. They're mixing these two solutions. Now they're asking you, what is the pH of the resultant solution? Okay, right. Now guys, this is just not from this chapter. It also involves little of stoichiometry, right? Okay. Now tell me, now look at this. Look at this. I have HCl, I have NaOH. Okay, now obviously that there's an acid, there's a base, right? So obviously these acid and base is going to react together, definitely, right? And obviously when an acid and a base react together, they form neutral solutions. Basically, I can take the H plus from the acid, I can take the OH minus from the base. Now they will react together to form H2O. Okay, right. Now if I want to find pH of any solution, guys, any solution, there is only one formula, right? The one formula is negative log of H plus concentration, correct? Right? Negative log of H plus concentration. That is what is my pH for any solution, for anything for that matter. Okay, now I have an acid, I have a base, right? Now they both will react together. So to form H2O. Now H2O cannot give me H plus concentration. Again, ideally speaking, like in the sense that it'll be very poor, right? Even if you take the pH of that, it is going to be 7. Correct, right? Now, if there is either the acid to be in excess or if the base is to be in excess, right? So definitely after the reaction has gotten over, right? After the reaction has gotten over, there will be still some amount of acid or base left depending on which is in excess. For example, if I see that the acid is in excess more than the base, more than the requirement, more than the stoichiometric requirement, right? If the acid is in excess, right? Obviously all the OH minus ions would have been gone, right? So obviously there'll be some residual H plus even after the reaction has been completed, right? Now that H plus has to be taken into this. Okay, Right. Now, if at all I have say I have base to be in excess. Okay. Now I cannot directly do this, but what I can find is POH. Hope you remember what is the formula of a POH? It's pretty simple. Instead of H plus, you have to write OH minus. So POH is negative log of OH minus concentration. Right? Okay. So if at all I say that the base is in excess, then obviously even after the reaction is completed, there will be some residual OH minus, right? Then you can find the POH, and hope you remember how do you find the pH from POH, right? pH plus POH is 14, right? So you can find the pH value also. Okay. Now let me do this problem. Maybe then you'll understand. Fine. So I have HCl, right? And I have NaOH. Okay. Now they have given me 200. First, I have to find the number of moles because I have to work with the number of moles here, or else I'll not be able to this thing, right? Or assume that they're going to form H2O. Like obviously they're going to form NaCl also, but that is not going to be important for us, right? So for HCl, let me calculate first. They have given 200 ml. And they have given the pH to be equal to how much? pH equal to 2. Okay. Or can I say that the concentration of H plus from this, I can write it as 10 to the power minus 2. Okay. 10 to the power minus 2 is what is the H plus concentration? Okay, fine. So I have 200 ml of 10 to the power minus 2 m solution of HCl. That's what you understand from this. Because it is a strong acid, whatever is the concentration of HCl, that will be the concentration of the acid. No worries. Again, this is a strong base. Whatever is the concentration of OH minus, that would have been the concentration of NaOH also. Okay, so let me do it for NaOH. Maybe little space I'll take. Okay, so for NaOH, if I have to calculate, right? So now they have given me it's a 300 ml solution. Okay, 300 ml solution, and they have given me the pH of this to be equal to how much? 12. Right. Now there is no point in finding the H plus concentration from this, guys. We have to find the OH minus concentration. OH minus concentration, if I find, then that will be the concentration of NaOH. Correct. So what will be the value of POH? Right. I told you pH plus POH is 14. So POH will be 2. No issues. Okay. Right. Now, what will be the concentration of OH minus? Same thing, right? Concentration of OH minus will be 10 to the power minus 2. Again, same thing. OH minus concentration is 10 power minus POH. The same thing how we do for H plus. Okay, so 10 to the power minus 2. Now that's what I have here for also. I have 300 ml of, okay, if I have some space, I'll write on 300 ml into 10 to the power minus 2 m solution of NaOH. Okay, now hope you remember, guys, molarity is equal to number of moles by volume, right? Molarity we know, volume we know, we can find the number of moles. Okay, that means you have to multiply. That's why I put the multiplication sign in between these two, right? 200 ml into 10 to the power minus 2 m, 300 ml into 10 to the power minus 2 m. Okay, now let me calculate the number of moles. Okay, so if I calculate the number of moles, obviously you have to put 1000, but we'll just do it as millimoles. Okay, so 200 into, or I can write it as 200 ml, I can write it as 0.2 liters. Okay, so I can write this as 0.2 into 10 to the power minus 2 is what is for the HCl, right? And for this NaOH, it will be 300 ml they have given. So it will be 0.3 into 10 to the power minus 2. This would have been the number of moles of HCl. This is number of moles of HCl. And this is number of moles of NaOH. Oh God, there's no space, guys. Okay, let me make some space. Right, this is number of moles of the stylus is actually sometimes it does like this, guys. Please bear with it. Okay, so this is the number of moles of NaOH, right? And this is the number of moles of HCl. Okay, so obviously from the stoichiometry, you can see the requirement is 1:1, right? That means for 1 mole of HCl, I have 1 mole of NaOH. I require 1 mole of NaOH. Okay, so that means if I have 0.2 into this much of HCl, I should have 0.2 into that much of NaOH also. But how much I have? I have 0.3. So which is in excess? Obviously, NaOH is in excess. Okay, so now tell me 0.2 H plus, that is this much H plus, this much OH minus will give me this much water. That is I would say the number of moles of water which would have been formed here would have been 0.2 into 10 to the power minus 2. That would have been the number of moles of water. Okay, number of moles of water is 0.2 into the power minus 2 because 1 mole of this, 1 mole of this, 1 mole of this will give 1 mole of this. That means 0.2 of this, 0.2 of this, and will obviously give me 0.2 of H2O. Correct? So now tell me what is remaining? How much is remaining? Can I say 0.1, 0.1 into 10 to the power minus 2 m, okay, point this much of OH minus or NaOH is what is remaining. I can tell you it as OH minus ions, right? This much amount of OH minus is still, what is the time, guys? Oh shit, I took so much time. Anyways, just give me 2 more minutes, guys. I'll not take much of your time. Okay, so this much amount of OH minus is remaining. Right, now that's it. I have found out the number of moles of OH minus remaining. Now I can find what is the concentration of OH minus. Okay, now this is the number of moles. Now concentration, how do I find? The number of moles divided by volume, right? Molarity is equal to number of moles divided by volume. Number of moles of OH minus remaining after the solution, after the reaction is completed, is I can write as 10 to the power minus 3 directly because 0.1 is 10 to the power minus 1. Right, so I basically have 10 to the power minus 3 divided by total volume, guys. It's not just volume of NaOH. They have HCl solution as well as your NaOH solution. So they have 200 ml of that and 300 ml of this. Total volume is 500. Obviously, I have to put 1,000 because it's an ml. I have to put 1,000 also. So now you know the concentration of OH minus. The concentration, right? The concentration of OH minus is known to you now, right? Now, if you know the concentration of OH minus, you can find POH from this, right? From POH, I can find the pH. That's it. Okay, now this question involves stoichiometry, concentration calculations, and the pH calculations. Okay, now I'll just take 1 more minute to explain you again, guys. Okay, so they have given me 200 ml of a pH solution of HCl that is equal to 2, right? And they have given me 300 ml of a pH solution of NaOH to be equal to 12. Okay, so first thing what I do is I have to do stoichiometry, because now if at all I have, after the reaction is completed, if I have any residual H plus concentration, or if I have any residual OH minus concentration, depending on which is higher, depending on which is excess, whether acid is in excess or whether base is in excess, right? Now I have to find out that which is the excess reagent, which is the limiting reagent here. Okay, so now I found out the H plus concentration of the HCl, okay, to be equal to this much, right? This much. I found out 10 to the power minus 2. Right now, we cannot find the we cannot find the OH minus concentration directly from the NaOH because pH is given, right? So from pH, I found POH, and from POH, I found the OH minus concentration to be 10 to the power minus 2. That's here, right? Then that's it. Now I have to do my stoichiometry. So let me calculate the number of moles. Number of moles is volume into molarity. Right. So I found the number of moles of HCl to be this much, that is 0.2 10 to the power minus 2. And this is the number of moles of OH minus or NaOH, whatever it is. Right. So obviously 1 mole requires 1 mole. So this is definitely the excess reagent. Right. So now I have to tell after the reaction has gotten over, how much of this will be left is the question. Obviously 0.2 of this will react with the 0.2 of this. Now this is gone. Done. So even after the reaction, you can see that this much amount of this much number of moles of OH minus is still remaining, or number of moles of NaOH is still remaining, right? This one, this value, right? This value, right? Now I know the number of moles of NaOH. I can easily find the molarity of the NaOH, that is number of moles of volume. Now, only thing I have to remember is you have to use the total volume here, not just the volume of NaOH. 200 ml of HCl, 300 ml of NaOH, total volume is 500 ml. You can easily find the OH minus concentration. Then again, they want to find the pH of the solution, but you cannot find the pH directly. You have to find the POH and then find the pH. Okay.
So we can
Guys,
do the same thing with H plus, no, sir, to get.
Yes, we can do, but if I can do that, if H plus was in excess. Now H plus is gone, right? The HCl acid is entirely gone. There is no H plus in the solution itself directly. The H plus concentration is 0.
With the remaining solution that's left, we are finding it, sir.
Correct. After the reaction has gotten over, if there is anything excess, that's what if there is anything remaining, that's what I'm checking. Is there any H plus? Is there any OH minus? I'm checking. And I found out for this particular case that OH minus concentration is in excess after the reaction has gotten over. That's why I find POH, then I find the pH. Yes.
So we had to use it for H plus. We'll just substitute OH minus with H plus everywhere, sir.
Exactly. So if this was ulta, if I had told you that the values are ulta, that is, I have 300 ml of for this and 200 ml for NaOH. If that was the case, then obviously you would have found out that the excess H plus concentration is 0.1, this value, right? Then you could have directly found the concentration of H plus, then the pH directly. That's it. Understood?
Understood.
Right? Cool. So guys, I hope everybody understood. Okay, fine. We'll meet again. I think I took so much time, right? Okay, guys, thank you so much. We'll meet again.
Thank you, sir.
Yeah.
Thank you, sir.